Hello, and thank you for watching how to set up a CI/CD pipeline for a .NET application with AWS CodePipeline and AWS Elastic Beanstalk. I am Sanjay Gulati, Senior Partner Solutions Architect here at Amazon Web Services. With Elastic Beanstalk, you can easily host .NET web applications without needing to launch, configure, or operate any virtual servers on your own. And using AWS CodePipeline, you can set up an automated release cycle for a fast and reliable application updates to Elastic Beanstalk. There are generally four major phases of the release process: source, build, test, and deploy. And with AWS CodePipeline, you can automate all the phases of the release process to rapidly and reliably deliver features and updates. AWS CodePipeline can be easily integrated with other AWS code services such as AWS CodeCommit for the source control repository, AWS Code Build to build and test your application, AWS Code Deploy to deploy your application to a production environment, and you can also perform blue-green deployment to avoid any application downtime. And all these AWS code services are fully managed services and you only pay for what you use. There are no upfront fees or any long-term commitments. AWS CodePipeline can also be integrated with other third-party services such as GitHub for source control, Jenkins to do your build and run unit tests, or you can also integrate with your own custom plugins. So let's take a look at what our pipeline is going to look like in this video. First, we are going to host our source code in AWS CodeCommit. Then, we are going to set up the pipeline so that whenever we commit our change in the code commit, it will trigger our AWS CodePipeline to build the application, run unit tests, and deploy the application to Elastic Beanstalk. So let's get started. Here I am in Visual Studio running on my Windows box, and I have the AWS Toolkit for Visual Studio installed. Also, to keep the demo simple, I have the default AWS profile set up on my local machine with full admin access to AWS services. For your production purposes, I would recommend to follow the least privilege principle and only assign the permissions that your developer needs. To save some time in the demo, I have the sample web application already created using Visual Studio .NET Core Web Application project templates. This is a very simple .NET Core web application that we will use for our demo and deploy to Elastic Beanstalk using AWS code services. Let's go ahead and run this application locally to make sure the project builds and runs successfully. Here you can see this is a simple vanilla web application. Let's go back to Visual Studio and look at what else we have in our demo application. Here we also have some simple dummy unit tests that don't really do much, but they will give us 3 passing tests and 1 failing test because of the bad URI exception. We will see more about running the unit test as a part of a CI/CD pipeline later in the video. There are 2 more plain text files added at the root location of the project, and to follow along with this demo, you can download these files from the displayed link. Let's look at those files. First file is called a process file. This is the configuration file that is internally used by Elastic Beanstalk to identify the process that it should run for your application. Here, we are telling Elastic Beanstalk that go ahead and execute the .NET executable with the application DLL as a parameter. And we are also configuring the URL where the app should run at. The second file is a build spec file. This file is internally used by AWS Code Build, which does the actual compilation. Essentially, it launches a container using a Docker image. Then it runs a series of commands to install any required software and perform the actual build or the test that you want it to run. Let's walk through the build spec commands. Here you can see there are 4 phases defined for the sample application. The first command executed in the install phase is to install the .NET Core 3.1 runtime. Then in the pre-build phase, it runs the command to restore the NuGet packages. In build phase, it builds the application and runs the unit test. And for the code build to report the test, we need to specify the logger format and where to put the logs. Here in the demo, I have changed the .NET test command to use the trx log format and to put the results in the test result directory. And in the post-build phase, we are executing command to publish the sample application and copy the proc file to the build output directory. Finally, in the artifacts node, specify the files that you want the code build to compress and provide to the code pipeline. In the sample, we are including all the files from the build output directory. And to have the code build use the trx files to create the test report, we need to add the report section. This report section grab all of the XML files in the test result directory to generate the test report under the report group in the code build. And we will see the reports in our demo later in the video. Now, as we are familiar with the sample application, let's go ahead and check in the sample application to AWS CodeCommit repository. The easiest way to do it is by using AWS Toolkit for Visual Studio. Let's go to the Team Explorer and find AWS CodeCommit, choose Connect. If you have a multiple AWS profile configured on your machine, then select the profile that you want to use for the code commit and then select OK. Once it's connected successfully, then it will show up as a managed connection and then choose Create. AWS CodeCommit repositories are organized by a region, so select the region where you want your CodeCommit repository to be created. For this demo, I will select the North Virginia region. In name, enter the name of the repository. I'm going to name it as AWS Elastic Beanstalk CI/CD Pipeline. In clone into, enter or browse the folder or directory where you want to clone this repository on your local computer. I'm going to leave the default path as is and then choose OK. AWS CodeCommit is just a Git repository, so we need to generate the Git credentials for the CodeCommit user. For that, let's go back to the browser and navigate to the I am user page in AWS console. Click on the user that you're using for CodeCommit and then select the Security Credentials tab and then generate the Git credentials for AWS CodeCommit. Download the CSV file containing the credentials and then let's go back to the Visual Studio. Click to import from CSV file and locate the file that you just downloaded on your local machine and then select OK. Once the repository is created and cloned successfully, it will show up as a local Git repository. Next, we want to copy the source code of the sample application to this empty Git repository and check it in using Git CLI. For that, right-click on the cloned repository under the local Git repositories and choose Open Command Prompt. Copy the path of the sample application and then copy the files into the local Git repository and check it in using Git CLI. Next, let's go to the Team Explorer and open the solution from the new clone directory. And to avoid any confusion with the source code directory, let's go to the File Explorer and delete the old directory that had the previous code. Next, we need to manually create the Elastic Beanstalk application as the code pipeline deployment provider for Elastic Beanstalk deploys to an existing application environment. The easiest way to do this is using AWS Toolkit for Visual Studio. So right-click on the project and click Publish to Elastic Beanstalk. On the wizard, choose the AWS account profile that you want to use for the deployment. From the region drop-down list, choose the region. I'm going to use US East North Virginia region to deploy the application. In the deployment target, choose Create a new application environment to perform an initial deployment of an application. On the application environment page, you can specify the application name. I'm going to leave the default name as is and choose the development environment. Check the availability for the URL, as this needs to be unique for the Elastic Beanstalk to host your website. If the URL for your website is OK, then choose Next. On the AWS option page, you can choose either Windows or Linux, but I'm going to select Linux since this is a .NET Core application and it supports Linux. For key pair, I already have the Beanstalk key pair created, and if you don't have an existing key pair, then go ahead and create one and select that key pair from the drop-down. And we can leave all the defaults as is. On the permission page, select deployment role that application will use to interact with other AWS services, and service role that Beanstalk will use to monitor the application. I'm going to leave the default value for the deployment and the service role as is, and choose Next. On the application option page, change the project build to release and change the rewards proxy to none to use Kestrel as an internet-facing web server. On the review page, review your changes and select Deploy. The information about the deployment will appear in the status bar and the output window. The deployment may take several minutes, so I'm going to pause the video and restart once the deployment is successful. Here we are. The deployment to Elastic Beanstalk took around 2 minutes. Let's go ahead and set up the automated CI/CD pipeline. Go back to the browser and browse to AWS CodePipeline in the AWS console and click Create New Pipeline. Let's name the pipeline as AWS Elastic Beanstalk CI/CD pipeline. I'm going to leave all the remaining defaults as is. Here it's going to create a new role for CodePipeline to use and set S3 as a default artifact and use AWS KMS for encryption. Choose Next. For the source provider, choose AWS CodeCommit, select the repository, and then select master branch. For detection mode, what it's asking is how you want to trigger your pipeline when the change is detected in your source code. If you select AWS CodePipeline, then it will periodically check for the code changes, and if you detect any change, then it will trigger the pipeline, else it will not do anything. But AWS CloudWatch is more efficient as it's more of an event-based model where it will trigger the pipeline automatically whenever the code change is checked in. So I'm going to leave the AWS CloudWatch as the change detection option. For build, select AWS Code Build and select the region. I'm going to leave it as North Virginia and choose Create New Code Build Project. Name the code build project. For consistency, I will name it as AWS Elastic Beanstalk Code Build Project. Next, we select the environment. For .NET Core application, let's select the managed images. For operating system, select Amazon Linux and select standard for runtimes and the latest available image. For service role, leave the default value. This role will provide the AWS Code Build the permissions to perform the build and push the artifacts to the S3 bucket. Under build spec, select the use build spec file. This is the file that we added earlier to our source code repository. Under logs, enter the group name. I'm going to name it as AWS.NET App CI/CD logs for the Amazon CloudWatch logs. This will output the detailed build logs for each build to the CloudWatch. I'm going to leave the rest of the settings as they are. Click Continue to Code Pipeline to save the code build configuration and return to the Code Pipeline wizard. And then click Next. Under Deploy Provider, select AWS Elastic Beanstalk as the deploy provider. For region, I will select North Virginia. In the application name field, select the Elastic Beanstalk application that we previously deployed to and select the environment that we also previously deployed to. Then click Next. Review all your settings and click Create Pipeline. Within a few moments, the source stage in your pipeline should move to in progress. It can take around 10 minutes or more for the build stage to complete, and then the deploy stage should finish quickly. So I'm going to pause the video here and then come back once the build stage is complete. Here, we are back in the pipeline. The build process took around 3 minutes and it's in a failed status, which also failed our pipeline. Let's look at the build details. Build failed because one of the unit tests failed. So let's go to the Reports tab for more details about the unit tests. Here you can see one unit test failed because of the bad URL exception. Let's go back to the Visual Studio and delete this unit test. Now as we are in Visual Studio, let's also go and update the index page and change the message from welcome to Beanstalk and check in changes. Theoretically, this should automatically trigger our pipeline. Let's go back to browser and check the pipeline status. Look like the pipeline is triggered already and is in progress. As the pipeline can take few minutes, I'm going to pause the video again and restart when the deploy stage complete. Deploy to Beanstalk just completed successfully. Let's check the URL to verify the updates. Here we see the updated index page that we committed earlier through Visual Studio, and it's got deployed successfully from Code Services. Thank you for watching and have a great day.